last presenter from Wisdom AI to hear Missouri.
Thanks, David. I'm going to talk about using AI to transform knowledge into wisdom for better dissemination and understanding of research outputs. I'm Tahir Mansoori, founder and director of R&D at Wisdom.ai, and I have been a startup founder and a computational biology researcher. So I'm going to give two examples on two ends, where in one case I was giving knowledge to someone, and one case where I was on the receiving end. As a startup founder, one of my friend left his job in investment banking in London to start his own startup. And he was going through the journey of a startup, raising funding and trying to grow the team and going the ups and downs of it. And we usually have conversations around like what are the obstacles and challenges that he was facing. And I read many books on startups, and two books came to my mind which were really important at the stage of a startup that he was at. And one book was Venture Deals, which talks about and demystifies that how the deals are structured, how the cap tables are made. And the other is Steve Jobs' biography, which talks about the challenges that Steve Jobs faced. And he found it really, really interesting and very relevant to his situation. The other is when I was at the receiving end, when I was doing PhD at University of Oxford in computational biology. And in my third year, I wrote up all of the experiments that I did in terms of chapters, and I wrote literature review. And I sent it to Professor Sir Mike Brady, who is an expert in this field of medical image processing. He looked at the draft, and his feedback came back, and he asked me, Tahir, did you read this paper, which was published just last month, and which is relevant to your research? And I looked at that paper and I was stunned because quite a lot of work that I was doing was very relevant, and they produced their result and published a paper. If I had looked at that, I would have done my research differently. But what was the limitation in that? As humans are really good at understanding the context, looking at the learner, that what is the knowledge that they're seeking and where is the gap, and recommending content based on that. But what I was doing, I was using Google Scholar, Web of Science, Scopus, and all the other systems, and typing keywords to search papers on medical image processing. There was no supervisor, there was no intelligence which was closely monitoring what I was trying to achieve and then recommending me exactly the content which I needed for my discovery and my research. And publishers are at the heart of this puzzle, because publishers' main primary responsibility is to take research and disseminate back to the research community in the most efficient way. And publishers have adopted technologies throughout the Industrial Revolution. The first Industrial Revolution was driven by steam, the second one by electricity, the third one by computing, and the fourth one that we are witnessing right now is powered by intelligence. And if you look at the first publication of Royal Society in 1665, it was handwritten, and then there was typewriters and printing press, and then publishing industry embraced online publishing by taking printed journals into PDF form and then in online HTML and XML format. But there is a long way to go before all of that content is made discoverable to people in a very efficient manner. I talked to technology teams at publishing firms, and what their struggle and their challenges right now is that many of the publishing companies are struggling with their own metadata, trying to figure out how to make their content more discoverable on Google Scholar, on various search engines to drive more traffic towards their content. But it still faces the same problem, that people are searching with keyword, with text, but they're not finding what they're looking for. And with 2.5 million publications published each year, it's really hard to keep tab on everything that is happening. An example is P53. P53 is a very important marker for cancer, and there are 70,000 publications published on P53, and a researcher on average reads 250 articles per year. If you spend your whole career, you're never going to get through all of the papers that are on P53 to do effective research in the field. So how do you stay ahead of that? That is publishers' responsibility to figure out ways to disseminate their content more effectively. And that is exactly the problem that we tried to solve with Wisdom.ai. So what we wanted to do was to build a whole picture of research ecosystem, but by not only looking at publications, but combining funding information, grant information, clinical trials, patents, social attention, and provide it to researchers and all the other stakeholders in the scholarly research ecosystem in a more effective way. So if you're a researcher, you would be able to understand that the AI would be able to recommend to you that what you're reading, what you should read, what are the emerging topics which are most funded. Funding bodies would be able to look at that data set and make decisions about where to deploy their investment. Institutions would be able to look at that and figure out that where they need to go and where they need to grow their competence, and publishing industry would be able to look at their data and figure out what are the emerging areas where they should publish, which authors to engage in. So that provides a 360 degree of R&D process. In our data set, we have 820 billion in research funding from NIH, NSF, from Australian, Canadian, and other funding bodies. We have 93 million publications. We have 1 billion in citations. We take all of this data set from various sources and we apply AI, machine learning, and natural language processes, processing all of the buzzwords that you heard about. And then we provide deep intelligence to help researchers and organizations not only measure, but also to assist them and monitor and benchmark their research and to achieve their goals. And these dashboards are very visual. We don't provide search results in a form where you need to download data and have a team of data scientists to analyze through Excel sheets or run like code on it, but it is like very visual where anyone, whether it is a researcher or an editor or a publisher, they can look at these graphs and get immediate insights. Going back to the first case study that I was talking about, that I missed a paper, during the early stages of when we were building Wisdom.ai, I was quite sure, after talking to a lot of researchers and having my own experiences, that no one is able to keep tabs on all the research that is being published. So one of my friends, he published a paper in Nature, and the co-authors were very prolific authors as well. What I did, I took that paper and I put it through our AI. It analyzed the content of that paper and references that were within that paper, and based on that, it flagged some of the papers that should have been referenced in the paper, but they were not. And I went back to that researcher and showed that, and he looked at that and he said that 4 of these papers he never came across and he didn't know about, but if he knew about it, he would have done his research differently. So it's quite amazing to see these kind of results. So what we are doing with Wisdom.ai, we are embedding AI into the research workflow by providing tools for researchers, by providing tools for publishers and institutions through contextual understanding to empower learning and discovery. And it is integrated at all phases of research life cycle. So whether researcher is doing in the reading and discovery phase, so we are able to suggest papers, suggest funding and grants, identify emerging areas when they are doing research. We are able to find collaborators. Some of the things are still like far in the future, but we have plans to integrate across the whole of the scholarly ecosystem. And it's not only for researcher, there is researchers are one stakeholder in the overall R&D ecosystem. Publishers are really key. You can right now go into Wisdom.ai and start a trial. And you can look at all of the journals and all of the content for 93 million publications. And you can look at like what are the topic coverage, what is the content coverage, and what is happening. And then you can add full text into that to optimize your content for delivery to researchers in a more effective way. And we are also helping institutions to look at their data set and look at where their authors are publishing and what they're citing. So librarians are looking at the data to make decisions about which journals to subscribe to. And the applications for that are throughout the R&D ecosystem. So we would like to work with publishers. We are already working with multiple publishers to get their full text to mine the data and to provide insights. And we would encourage you to start a trial to get deep insights into your existing content and metadata that we receive from Crossref and PubMed and other places. Find us at booth 219 and follow us at wisdom.ai.
All right, well, thank you very much. We have just a few minutes left, and I thought that we would open it up to the audience if they had any questions that you'd like to ask of any of the panelists about anything they said today. Raise your hand. Yes. Sorry.
Hi, I can't remember exactly who gave the example of the internet disrupting newspapers, but I have a question. How well do you think AI would detect that, given that it might do like regression analysis? How good do you think it would be at actually finding a trend that's going to happen very, very quickly?
God, you didn't remember it was me? Just kidding. I'm only slightly hurt. So I think your point is well taken. I think AI that is trained on a certain batch is not such of data, and you're seeing this problem with stock markets now too. Is like everybody's like, oh, I've got a really brilliant AI because it's learned everything about history, but history, the past is not necessarily the future. That said, there is really powerful AI in anomaly detection. And anomaly detection is not so much are you predicting whether something is going to keep going that direction, but is something happening that's unexpected? And then a human can follow up and investigate if something's happening that's unexpected. So I think, that wasn't necessarily a failure of prediction. I think it was just simply who could have thought that that smartphones or the internet or any of that. I think the right thing to do there is be like, all right, what's the worst that could happen if this actually became the most important way that people consume media at all? Maybe we should invest 20% of our budget or a little bit of our budget, just in case. I think that's probably the more prudent approach. But yeah, so the answer to your question, probably anomaly detection, although your point is well taken. Yeah, like garbage in, garbage out.
Just to pile on that, I looked at the Gartner hype cycle for 1996, and the World Wide Web was at the very peak of its hype cycle back in 1996. So just so there for predictions.
Anybody? Sure. Here.
So again, going back to your presentation, you talked about using a lot of data and that publishers had a lot of well-curated, well-maintained data. But one of the things that our keynote yesterday talked about was bias introduction and how effectively a lot of what we publish is inherently biased. So then are we not training these AI models with that bias?
That's a great question. I don't actually think that the data in our case is inherently biased. So just to give you a sense of like how we do what we do, we ingest all of those papers, and then we actually have PhD biologists tag individual sentences so that the machine gets 10,000 samples for every use case that we're looking at. And then based on that, it understands how to read any other sentence that looks like that. The bias that it's inferring in that case is a good bias because it's inferring the bias of a PhD biologist, which is exactly what we want it to have, that person's bias, which is why they're the ones labeling it. So in that case, the data is the raw material, but it gets filtered through humans who then train it, and then we actually want their bias, which is why we use them. I think the other thing to think about is that, number of citations, it may be a good indicator to a scientist of whether or not a product is one that they want to buy. It's not the only one. They'll want to look at some other signals, but there's a lot of signals in the data that either are biases that you want or are things that aren't necessarily biased and are very useful. Just it's important to be aware of it.
I think we have time for one more question, if any. Please.
Maybe you can hear me from here.
Sure, I think they're recording it, so that's one.
There are some predictions that say within the medium term, something like 80 to 90% of jobs as diverse as lawyers, truck drivers, will be made superfluous by AI. Can you, as a panel, comment on, do you believe that is a valid prediction, and how long is it before we reach that point?
Does anybody want to take that?
So I just read a prediction last night that said 40% of all the tasks that data scientists do will be automated by 2020. So the platforms and the analysis and the work that people do in terms of the grunt work, if you like, of data science, preparing the data, cleansing and everything else will be handled by platforms that are in process now and will be perfected in the very near future. So you can just see if the idea that the algorithms can be created faster and cleaner based upon these platforms being developed, you can just project the curve is going to continue to rise.
Anybody want to add on? Yeah.
Well, so we've seen in the legal profession, certain tasks that were, brute force tasks have long been replaced by computers, and yeah, that might be a factor in the reduction of the number of legal jobs. On the other hand, it's work that frankly might as well just be given to a brute force machine and let humans do something else. It gets to your whole sense of optimism and pessimism about the future. Do I feel this is fundamentally different from 1800 and the Luddites, where the machines were going to take away the jobs from the people who were, doing the weaving or whatever it was? And the answer was yes, they did take away those jobs. Those coal jobs aren't coming back no matter what our policy is, because they've been replaced by automation. There are jobs that continue, and there are people who win and lose in every one of these cycles. And I think this is just one more tool that will affect that.
Right.
Please. So I follow this very, very closely, and my personal opinion is that everybody who is saying that the jobs aren't going away, they're just saying that because they have a stake in people not freaking out while they build the technology that automates away the jobs, right? It's like the people at Uber or Waymo, or they're like, no, the humans will still keep in the loop, but I think the stark reality, if you look back at all the industrial revolutions, as you pointed out, the way that humanity coped with that typically was shortening the work week. The work week got shorter and shorter and shorter as we rolled out more and more technology so that we could maintain quote-unquote full employment. Personally, I'm all for full unemployment. I just think we have to find a way to deal with the wealth inequality, and we have to find a way to give people meaning in their lives outside of their jobs. And then people will say, well, we'll create new jobs. If you look at the history of that, it actually doesn't happen. Max Tegmark has a great book I encourage everybody to read called Life 3.0, and he points out that there's been virtually no new job category created other than software developer. All the other jobs we have today are the same jobs we always have, we just have fewer and fewer of them. So that's my answer. I think we'll cope by shortening the work week, and probably through some sort of wealth distribution mechanism that people in the US don't like to talk about, but it's but in where I'm from, we're actually doing a universal basic income experiment now. I'll shut up.
Right.
Simon, can you call my boss about that shorter work week?
That's right. Well, anyway, I wanted to thank Jim from Highwire, Roy from Copyright Clearance, Simon from Benchside, to hear from Wisdom AI. Give me a round of applause. Thank you very much. Have a nice day.